Morning. Now we are going to see about the another topic is magic tea from the microwave optical engineering subject. What is an hybrid? That is magic tea or H plane T. It is a combination of E and H planes. A hybrid junction is a four-port network, whereas E plane T has three-port network and H plane has a three-port network. Whereas in this we are having a four-port network. That is a combination of E and H. A magic T is a combination of E and H as previously I mentioned. Now it is represented as port 1 and 2 are collinear arms, port 3 is a H arm, port 4 is a E arm. Rectangle slots are width, cut along with the width and breadth of along long waveguide and side arms are attached. See, as we mentioned H arm and E arm as port 1 and 2 as collinear arms, that is input sections or output section we are using out, and E arm will be used for port 4 and port 3 as H arm. Port 3 as H arm and port 4 as E arm. The diagrammatic representation and pictorial representation has been represented here. See, the characteristics of magic T. Okay, the characteristics of magic T. If two in phase of equal magnitude and fed into port 1 and 2 the output at port 4 is subtractive and hence 0, and the total output will appear additively at port 3. That is, port 4 is your difference arm and port 3 is your sum of arm, that is H arm. We already discussed in E plane T and H plane T, that also here mentioned, that is E is difference and H is sum. So from the E plane and H planes T, we already knew about those things. So S43 is equal to S34 is equal to 0 and S12, S21 is equal to 0. From that, the collinear arms we are mentioned and port 3 and 4 we are mentioning here. Okay. For ideal lossless magic, the T magic at port 3 and 4 is equal to S33 is equal to S44 equal to 0. By the representation of all things, we are saying about S matrix as 4 matrix and mentioning here symmetric matrix also. Yes, Ij is equal to Sgi by the equation we are representing here. And port 3 as S23 is equal to S13 and port 4 S24 is equal to minus S14. By substituting the equations from those equations, we are obtaining an scattering matrix into a T junctions as it magic T's. Using unitary property and on equation 8, we are multiplying that S into S matrix is equal to 1. That is, unitary matrix is nothing about S into S transpose is equal to I, that is unitary matrix. That we are seeing about here. That has been mentioned and represented here. So by that equations we are obtaining an row into column, that is row R1 C1, R2 C2, R3 C3 and R4 C4. That is S11 into S1 star is equal to S1 modulus of squares. Like this, all things has been represented here as equal to 1. From those equations we are telling about from the equation, by equation 9 and 10 we are getting out S11 is equal to S22. From equation 11 also we are saying about S13 is equal to S13 square plus S13 square equal to 1. So S13 square is equal to 1, that means S13 square is equal to 1 by 2. So S13 is equal to 1 by root 2. Similarly for S14. See, by the equation substituting we are getting out the equations, and finally we are saying about S12 and S11 equal to 0 from the above substituting equations. And also from the equation 13 and 16 we are getting S22 is equal to 0. The S magic T is obtained by substituting the scattering matrix parameters from equation 16 and 17, and we are saying about S1 is equal to, that is S matrix is equal to, from the equation 18. By substituting those equations into the platforms of what we obtained, So scattering matrix is equal to 1 by root 2 of those matrix as represented. There is 0 0 1 1 and 0 0 1 minus 1 1 1 double 0 and 1 minus 1 double 0. Like this equation has been connectively substituted and the answer is obtained by the scattering matrix. The application of magic T. The magic T is measurement of impedance as a duplexer, as a mixer, and as an isolator. So magic T as a duplexer, it is a duplexer circuit means the input will be get from one section to another section and another section to the same section. That is reverse of operation will be obtained. Okay. So main the duplex application is applied for those things. Okay. Any query? Thank you.